This lesson is on electroplating. For electroplating, we need an electrolytic cell. So we want to plate some metal with silver to make silver plate. So when you have silverware, there's sterling silver, that's 92.5% silver by weight. And then you have silver plate, where you have a less expensive metal that gets coated with silver. And so that's what we're going to look at the process for how you would do that. So here we have a hunk of pure silver. We have PS, that stands for power supply. We're going to force a current. And then here we have our fork that we want to get coated with the silver. So notice we do not have two separate cells. We do not have a salt bridge. This can all be in one beaker because when the power supply is turned off, we're not going to get any reaction. When the power supply is turned on, we're going to force the electrons to travel from here down to our silver fork. So what is going to happen? Here, electrons are leaving, so this is the anode, and the silver is going to undergo oxidation. So on this side, we're going to have Ag going to Ag plus an electron. So every time an atom of silver comes off as Ag plus, an electron leaves. Oh, and we also have 1 molar silver nitrate. So we do have some silver ions and nitrate ions in our solution. So the electrons move, and then we have an electron comes in to the fork. So an ion of silver then comes onto the fork and plates out. So this then is our cathode, where we have the reduction. So here Ag plus an electron goes to Ag. So we make a silver ion. The silver ion gets turned back into silver. So we don't need any salt bridge because we have electrical neutrality here. Every time we produce a plus, we take away a plus. So that's how the silver from this electrode gets transferred to the silver on this electrode. It's through the silver ions being put into the solution and then being taken out of the solution. All right, so now we'll just do a problem involving that electrolytic cell, and we've seen these type before. So how many grams of silver can be plated with a current of 15 amps for 1.00 minutes? All right, so we know that our amps means we have 15.0 coulombs for every 1 second. So that's the amount of charge traveling through the wire every second. All right, so X grams of silver equals 1.00 minutes. And we know that there's 60 seconds in 1 minute. Okay, now we can use our amp conversion factor. So we have 15.0 coulombs of charge for every 1 second. And now we want to change those coulombs into moles of electrons. So we use Faraday's constant. 1 mole of electrons carries a charge of 96,500 coulombs. All right, and now for silver, going back to our cell, for every 1 mole of silver that gets plated, we need 1 mole of electrons. It's a 1-to-1 ratio. So 1 mole of Ag gets plated out for every 1 mole of electrons. And then we just need to get the mass of silver, the molar mass, 107.87 grams of silver for every 1 mole of silver. So everything is canceled except the grams of silver. And let's do that calculation. So we've got clear 60 times times 15 divided by 96500 times 107.87 equals, let's see, with 3 sig figs, we have 1.01 grams of silver that gets plated onto our fork. All right, so now we're going to consider, suppose we have a mixture of ions. So we have some lead nitrate making lead Roman numeral 2 ions, zinc nitrate, Zn2 plus ions, and silver nitrate, Ag plus ions. So when we add a power supply, are we going to get the lead coming out first, the zinc, or the silver? How does that happen? And so for that, we want to look at the reduction potentials. So we go to our reduction potential chart, and let's see, let's look for lead. Oh, here's lead. So Pb plus 2 plus electrons is a negative 0.13 volts. So Pb 2 plus 2 electrons goes to Pb solid. That's what happens. The lead ions turn into lead, get plated, and we saw that our E0 is negative 0.13 volts. All right, let's check out the zinc. So we check our chart. Here's our zinc, and that is negative 0.76 volts. So that is Zn2 plus 2 electrons going to Zn. And then for silver, it'll be Ag plus 1 electron, plus an electron goes to Ag. And let's find our, there we are, 0.80 volts. So our reduction potentials are going to give us the answer. The reduction potential, the higher that is, the greater the tendency to be reduced. So silver with the greatest potential has the greatest tendency, so it's going to be reduced first. So we have Ag, plates first. The next highest reduction potential is the lead. So Pb plates next. And then finally we have our zinc. So it has the most negative value, so it's going to plate last. All right, so when you have a mixture of ions, just look at your reduction potentials, and the higher the potential, the more easily it's going to plate out. All right, that's it for today.